So, good morning, everyone. How's your day so far? Good. Yeah, I really love this event and learned a lot today. So, I feel a little bit nervous, to be honest speaking, but I feel more excited. So, this is my first time giving a presentation in a research conference, and I will be presenting my recent work these days. It's early stage, but it's interesting. It's Persona Coder, how personality influences the coding performance of large language model-based agents. This work is collaborated with my supervisors, Professor Harry Wang and Professor Chenchuan He, and also a professor from Chenchuan University. Okay. Before I actually jump into the presentation, I wanted to ask you guys a short question. In terms of personality, are you an extroversion people or introversion people? If you're extroversion, can you please raise your hand? Good. And if you're introversion, can you give me a firm eye contact? Okay. So I did this on purpose is because I believe personality will guide people's behavior, largely speaking. And surprisingly, we did an experiment last summer. We let the large language models to perform the MBTI personality test. And we find large language models, they also have personalities. For example, GPT 3.5 has personality ENTJ, which is like Steve Jobs or Gordon Ramsay. And GPT 4.0 has personality which is like INTJ, which is like Michelle Obama or Elon Musk. So, what happens inside? And recently, the top AI conferences, these 5 papers, they covered one thing, except the original personality of the large language models. Large language models can also be assigned to a certain personality using prompt engineering. And our work here will look one step further. In the past, people have shown that personality will affect the performance of single LLM agents in areas like safety, fairness, and even coding. However, considering the tasks become more complex, there's always a need for multi-agent team. And we have a lot of discussion this morning, right? And also, there's a growing interest in the success and failure of the multi-agent systems. Then it comes to a question here. Will the personality affect multi-LLM agents in a team, an area that is underdeveloped? So we raise our research question. How does personality affect a multi-agent system? Specifically, we will introduce this with 3 levels. First, the performance, needless to say, everyone looks at it. Second, the actions the large language models take. This is one step further, because past research mainly focused on a single turn generation of the large language models, which means there's no agentic behavior, there's no autonomous decision making. However, we cover it in our research. And second, the communication patterns, which is essential for any team-based performance. Now let's look at our empirical context. Our empirical context will be based on a complex coding task. You may want to ask first, why we use a complex coding task? Will personality, does it affect also on the simple benchmarks? Well, the answer here is straightforward. For the simple benchmarks, large language models can solve them with a 90% accuracy within a single turn generation. And then it will leave no room for the agentic behavior and there is no room for team performance. So we select this on purpose. Specifically, we use SW Bench verified benchmark. This benchmark is built on real-world GitHub issues. And OpenAI hired 93 of professional software engineers to make human annotation to this benchmark. So this benchmark is solvable, it's objective, and it's of high quality. And it's relatively new with launching less than a year, and it's relatively complex. With the SOTA model, with agentic behavior, only being able to solve 62% of the tasks. So, in terms of our research setup, we assign the team of the agents in a pair programming setting. Specifically, we will have one driver agent and a navigator agent. Unlike traditional human pair programming where there's a role switching between the driver and navigator, here we do not have that. we use one agent for the driver always and one agent for the navigator always. And for the driver agent, it follows a React framework, which means when giving a response on he wanted to make an action, he will first have an internal thought and then followed by an action. And the internal thought will not be observed by the navigation agent, while the action can be observed by the navigator agent. And for the actions, we split it into 4 categories. First, it can search or browse the file system. Second, it can modify the files. Third, it can execute the code scripts. And fourth, it can ask questions to the navigator agent. So, in this kind of framework, the driver agent is pretty much like a human real being doing a software engineering task, looking at the code scripts, modify them, and running them, right? And after assigning the roles to the agents, we'll also assign the personalities to the driver, to both the agents. Here we specifically use Big 5 personality traits. Here I wanted to use extroversion and introversion as example. As the personality theory states, extroversion is related to people being active, assertive, energetic, enthusiastic, outgoing, and talkative, while the introversion people are being the reverse. Following these adjective descriptions of the personality, a paper published in 2022 Neurops by Jiang proposed a prompt method called personality prompt method. And they proved that with these prompt methods listed here, they can induce the personality of large language models. Let's read one of them. So extroversion will inject this prompt into the system prompt, like you are a very friendly and courageous person who loves to be around others. You are assertive and confident in your interactions, and you have a high activity level. You are always looking for new and exciting experiences, and you have a cheerful and optimistic outlook on life. And the introversion prompt is on the other side. So, after assigning roles and personalities, we will give our task to the agent team. And the agent team will perform like this workflow when solving our task. First, the driver agent will take an action. And the action will be observed by the environment. And the environment will give a response to both the driver and the navigator agent. This process loops unless if the driver agent takes 3 consecutive actions, and then the navigator agent will give a comment and suggestion to the driver agent. Or when the driver agent asks a question to the navigator agent, the navigator will give the feedback to answer the question to the driver agent. And ask a question here is also counted as an action. So the driver agent, we set it to be at most perform 40 actions to solve a task. Or it can have an early stop to submit its changes to the code base. And here's our preliminary experiment. Here we on purpose choose the 2 pairs. One pair is of the extroversion personality, meaning both the driver and the navigator agent forms the extroversion personality, and the other is introversion personality. Both the agents are being introversion. And the model we used is GPT-4o, and we sampled 25 out of the 500 tasks from SW Bench Verified. And the sampling follows the exact difficulty distribution, and that's the lowest level that we have each task difficulty level to each task. So you might want me to ask why we select these 2 pairs. And I wanted to say, as it's an early stage research, we select these 2 to show here on purpose, as documented in human research. There's the most distinct and apparent contradiction in the communication styles of the extroversion people and introversion people. And extroversion people is believed to be more linked to procedural thinking. So we select these 2. And asking each of the agent teams to solve the 25 sampled tasks for exactly twice. Now let's look at our results. Our results here shows the introversion paired team performs better than the extroversion paired team. And here is the task resolve rate by personality type. Task resolve rate means the number of tasks being solved by the agents over the 25 sampled tasks. And we wanted to know why, right? Since its performance is different, it must have to do something with this agentic workflow. We step one step further and find the action differences. We find the extroversion agents actually needs more steps when completing a task compared with the introversion pair. And one step further, we find when we further categorize the action types, we find the driver agents will take more code execution and the modification actions. On the other hand side, the navigator agent will take more searching actions. This is quite interesting. The extroversion agents tend to take a more trial and error approach, while the introversion agents tend to take a more cautious and information gathering approach. And if you can recall this, have you ever used Cursor or Windsurf? Okay. If you have ever used it, have you ever set a rule saying to the agents, do not guess what the code looks like. Look at the code base and then find out the logic, finally add their logic. And this is exactly why introversion agent pairs performs slightly better here compared with the extroversion agents. And the third, we check the communication styles there. We'll find when asking questions, the driver agents asking question on average that is 70% longer compared with the introversion pair. And the navigator agent, when giving feedback or answering questions, they have an on average 14% longer response compared with the introversion agents. Now let's have our conclusion here. That's our preliminary results. The conclusion here is straightforward. Personality, when setting a team settings, they do influence the performance of multi-agent systems, and they influence not just via the accuracy, but because they also influence the actions and communications of these agents. This is quite interesting. And in the future, we plan to expand to more personality traits and find more optimal personality match and also make more robust tests there. So thank you for listening. It's all of my presentation. Thank you. Yeah. Before I started the Q&A session, I wanted to say a few words. Since it's an early stage research, I do welcome any feedback, response, suggestions, comments. Yeah, it will definitely help us to refine and improve our work. Yeah. So, any questions or suggestions? Yeah, sure.
Yeah. So you only look at the pairs of EE and II. So do you think the pair between extrovert and introvert would perform better? And also, do you think their performance depends on the types of the text? Because if it's a social related text, maybe both extroverts would perform better.
Yeah, that's a great question. So the first question you ask is, what's your first question?
The pair between extrovert and introvert.
Yeah, we'll definitely incorporate them in the future. And I slightly guess that the introversion driver with the extroversion navigator will be better. I don't know, but that's a guess, a hypothesis that we can make, right? And for the second question, as it's a coding task, so you might, you can be right, and also I don't have a firm answer here because it's a coding task, not a social media task. So I don't know. Maybe it will be, maybe it will not be. Yeah, sure. Yeah, you can.
So I had a question on the maximum number of output tokens, because if it's extroverted, then the agent would generate more number of tokens.
Yeah.
And if you have a cap on the maximum tokens, then the task might not be performed well by extroverted pairs. So did you play around with the maximum token?
Actually, here we don't set a maximum token. We set maximum number of steps, the actions the driver agent can make.
But the output tokens, the LLMs would have some...
Yeah.
Our experiment never exceeded the maximal context window, but I think if you want to limit the what the actual agent can say in one turn, that's more like asking me to shut up, right? So that's very interesting, but we haven't tried it. But I think that will affect the performance. Meaning is just don't express stuff, right? We haven't done that yet. Thank you.
Yeah. Sorry.
Yeah.
Robustness checks are pretty hard in general with prompt engineering stuff. There's lots of different ways you could do it. have you just tried not giving a personality as a control, like a EE, II, and then one like just no personality given, and just see if just having no personality just gives a very specific task and gives you better outcomes?
Yeah. That's a great idea. Actually, we have two baseline experiments we didn't show here is because surprisingly, when drawing the figures, one thing I should mention first is that personalities, large language models that have a predetermined personality, just as we described before. And we surprisingly find that the baseline performance is in between. If you draw a graph like this, surprisingly, it's in between. And we don't want to talk too much here, so we don't include this. So, and I think in the future, we will definitely talk about this. Yeah, sure.
I think it would be interesting, right? So some of the personalities, right, of the base models, unmodified, are probably driven by the fine-tuning of the models when they created. So we're interested to see basically whether this can explain some of the differences between, say, Claude and ChatGPT, for example. It's like Claude, I think, is better at coding than ChatGPT, maybe. And you started your presentation, you can measure that somehow.
Yeah.
So it's interesting to see basically what is the baseline personalities and how they affect. Does it correlate with the results or not?
Thank you.
Time for one more question.
Okay.
I'll try and be quick. It's kind of pretty much in alignment with one of the questions that's asked. So, have you tried to assess the default personality? So you're injecting, let's say, II or EE, which is fantastic. And you said if you have not injected anything, the default is kind of in between. But have you tried to assess it and across different LLM models? So.
Yeah. Actually, these CS papers they have tested, and since we use the exactly same prompt, we don't further test it. Yeah, and the results shows since we all know big five personalities they scale between 0 and 4, right? And if we assign prompt engineering to introversion, it's around 0 to 2, something here there, and we assign it to maybe to extroversion, it's around 3 to 4. And if we do not assign, the score will be for GPT-4o, it's slightly smaller than 3. So which means 3 or? Yeah, slightly smaller and it's slightly introversion. Yeah, that was the test result by those CS papers. Yeah.
Thank you.
Thank you very much.